Now let's look at the Liskov substitution principle. Before I get into the principle itself, I'm just going to quickly remind you what substitution means. So remember that we can have a type and then we can have a subtype, and that subtype is always substitutable for its supertype. That means that we can declare a variable to be of a certain type and then instantiate any of its subtypes to use for the implementation. It also means that we can declare a parameter to be of a type and then pass in any instance of one of its subtypes. The Liskov substitution principle turns on not whether you can substitute one type for another, but whether you should. So let's think about this arrangement of classes. This is one of the classic examples when talking about this principle. So we have a bird, and then we have kinds of birds. We have an eagle and we have an ostrich. And this all makes sense because in our minds, both an eagle and an ostrich are birds. But let's think about how we've defined a bird to be. A bird can eat and lay eggs or whatever, and a bird can also fly. Now, an ostrich cannot actually fly. An eagle can, so that's awesome. But if we have a method like make fly, and we pass an ostrich in, then this method becomes a little strange. We don't know what this ostrich should actually do in this case. It isn't actually a great subtype of bird, because if you want a flying thing and you get an ostrich, then you're going to be unhappy. The Liskov substitution principle has a lot of different components, and we're focusing on this one. So what do all these things mean? Well, a postcondition is kind of like the effects clause that we would have used to specify our methods, and a precondition loosely corresponds to the requires clause. So weakened and strengthened, we're going to get into in a minute. But what I'm going to tell you about now is just a quick way to remember which should be weakened and which should be strengthened, because I find that people have a really hard time remembering which is which. So if we think about an operation that cannot be substituted, then it might be a sad operation. So it might have a frown. If we think about what a frown looks like, it's wider at the bottom than it is at the top. If we say that the top are the preconditions, then those can be narrower. So here we can have strengthened or tightened preconditions. At the bottom, we can have looser or weaker postconditions. The opposite is also true. So if we have a happy face, that means that we have a substitutable method. A happy face has a smile, which is wider or looser at the top, so we have weaker preconditions. And it's tighter or narrower at the bottom, which means we have stronger postconditions. And an operation with this arrangement is substitutable for its supertypes operation. So now let's really unpack what weakened and strengthened means, like what it looks like when you're dealing with a particular class, subclass arrangement. So here we have a doctor, and a doctor has a book appointment method. And then we have a subtype specialist, which overrides that book appointment method. And the doctor's book appointment method accepts times in a range of 9 to 5. So if you want to book an appointment at 9 a.m., you can, if you have a doctor. However, the specialist only allows bookings from 10 until 2. And that means that if you were to call doctor.book and this doctor had been declared to be a specialist, that this would be unhappy because the preconditions of this implementation of the method are stronger or narrower than the preconditions of this one. This one has a requires clause that the parameter be between 9 and 5, and this one has a narrower requires clause that the hours be between 10 and 2. So this book appointment is not substitutable for this book appointment, which means that the whole class becomes unhappy. The specialist is not substitutable for a doctor. So once you've realized that you have an unsubstitutable subclass, what do? Well, there are lots of ways that you can resolve the situation, but there are a couple of pretty simple approaches. So in the case of your bird, eagle, and ostrich, what you might want to do is make a flyer or flyable interface. And put all of the behavior related to flying inside of that interface. And so then you would make the eagle and any bird that can fly implement that interface. That way the ostrich would have no expectation of having to fly at all, which is great. In the case of the doctor and the specialist, what you might want to do is rethink the relationship between the doctor and the specialist. The specialist was really subclassing the doctor just to be able to get at all of its cool operations. But another way that you can get at something's operations is to use one of them, so to have one as a field. So instead what we might want to do is change that extends relationship into a uses relationship, or build an association from the specialist to the doctor. So we would build the specialist class such that it had a doctor field. Then it could call all of its methods and effectively wrap all of the methods of the doctor for its own purposes. Then there would be no expectation that it had to live up to all of the things that a doctor can provide, including the range of appointments. The list cost substitution principle is a really great way to know whether you have a valid substitutable subtype. However, there's an even simpler collection of ways to just sort of intuit whether your subtype is actually substitutable for the supertype. So here are just three simple ways to think about the subtype-supertype relationships. The first one is a substitution test. Just try substituting it. So you might declare something to be of the supertype, and then try substituting the subtype. So you might say student S equals new student registration system. That makes no sense. A student registration doesn't make a very good substitution for a student. However, if you were to think bird B equals new eagle, this would feel pretty natural. An eagle is substitutable for a bird, especially if it can fly. The concatenation test is another nice way to intuit whether you have a proper subtype. So if we were to say eagle bird, that would feel very natural. But if we were to say student registration system student, that would make no sense at all. So by concatenating the words together, you can sort of tell whether you have the right subtype. But the mother of all of these intuition-based reasonings is the ISA test. Is the subtype a supertype? So if we say an eagle is a bird, this makes complete sense. However, if we say the student registration system is a student, this makes no sense at all. So this tells us that no, student registration system should not be a subtype of student. Now, why would you have made it a subtype at all? Maybe because you wanted to use some things that were inside of student. Just like our previous specialist doctor example, you should make that a field or an association, not a subtype relationship.